Hey everyone. We are going to talk a little bit today about Newton's second law problems. And I'm going to talk about kind of three different levels of Newton's law problems. So one of the things you might have noticed as we've been studying forces is there's really one core equation that all of these problems come down to. And that is that the net force equals mass times acceleration. And we talked a little bit about static equilibrium problems in this other video. I'll put a card up here. And those are special because in those cases, the acceleration is zero, it's not moving. And so in those cases, it's really centered on the even simpler equation, net force equals zero. Today, we're going to look at problems where that's not true anymore, but we do still get to use Newton's second law. And so we're going to start with something pretty straightforward. What if I have a box? And on this box, I'm exerting two forces, a force to the right of 200 newtons, force to the left of 50 newtons. And we can say that this box has a mass of 5 kilograms. And I want to know a couple of things. First of all, I want to know what the net force on that box is. And specifically here, I'm talking about the net force in that x direction, the side to side net force. And then I want to know what the acceleration of the box is going to be. And from here, by the way, part C would probably be what I call a big three problem, something kinematics based, like how long does it take to get to a certain velocity? How long does it take to travel a certain distance? All of those are possibilities for C. But today we're going to focus on kind of just the force part, which is the net force and the acceleration. So the net force in the x direction is all of our positive x forces. And in this case, we only have one, 200, minus all of our negative. And again, we only have one, 50. So what is our net force? It's 150 newtons. And it is positive, which means it's going to the right. Now, to figure out what our acceleration is going to be, we're going to go back to that key equation, which is that net force equals ma. And the cool thing about physics is that we can break it down into any direction, right? So here we're really just worried about the x direction, and that's going to tell us about the x acceleration. So let's plug it in. We've got 150 newtons is our net force. Our mass is 5. So we can divide both sides by 5. We're going to get an acceleration of 30 meters per second squared, which is like super, super fast. This is not particularly realistic, but that's also quite a bit of force on a very small box. So this is the simplest kind of second law problem that you can get. I give you the forces, you tell me the net force, you tell me the acceleration. We can take it up a level, and to take it up a level, we're basically going to have a situation where you need to tell me not just the net force and the acceleration, but maybe you actually have to calculate one of the forces. So here, let's have a 5 kilogram ball, and it's falling, so it has a force of gravity acting on it. But there's also a force of air resistance acting upward. If you take AP Physics, you'll dig into air resistance in a lot more detail. And you'll get to learn a little bit about exactly how would we find that force, and you'll actually find that it kind of depends on the speed. We're going to take the simple route here, and we're just going to say it's 9 newtons. And so I'm going to ask 3 questions here. So what is that net force? And here, we're interested in the direction of motion. So we're interested in the net force in the y direction. And then we're also going to look for the acceleration. But before we can do any of that, kind of step 0 is we have to calculate the force of gravity on this object. And so the force of gravity is the mass times negative 9.8, which is negative 49 newtons. So I can say that this is 49 newtons down. All right. One big issue I see when I ask people, what's the force of gravity? A lot of times I get a shout out of negative 9.8. Please remember that negative 9.8 meters per second squared is the acceleration due to gravity. It's how quickly an object will fall if gravity is the only thing acting on it. To find the force of gravity, we have to multiply that acceleration by a mass. And if we think about that, right, that kind of makes sense. We need a bigger mass to accelerate a bigger object. We need a smaller mass to accelerate a smaller object. So then if we look at the net force in the y direction, what do we have? We have 9 upward and 49 downward. So we have a total of negative 40 meters per second squared. And then to find acceleration, we're going to do net force equals mass times acceleration. So negative 40 equals 5a. A is going to be negative 8 meters per second squared. And this is a really good time for you to think about whether or not that answer makes sense. And that's something I recommend that you do in almost any physics problem. Is if it's something that you have a kind of an intuition for, then ask yourself, like, did the answer I just gave actually make sense, or did I miss something? In this case, we see that if the object were just falling with gravity, if we didn't have that air resistance up there, then it would accelerate at negative 9.8 meters per second squared. But we do have air resistance, so we know it's not going to accelerate quite as quickly, but it should be kind of on the same order of magnitude, the same size, just a little smaller. And sure enough, negative 8 meters per second squared fits the bill. So it does make sense as an answer. All right. Now let's think about kind of a fairly difficult second law problem that is still like introductory physics level and not quite like AP level. And for that, I think we're going to need to resume our friendship with the force of friction. So I'm going to have an object, 10 kilograms, and it's got lots of forces happening. It's got a force of gravity. It's got a normal force. It's got force of friction. And let's say I'm pulling it with a force of 100 newtons. We'll say that the coefficient of friction between the box and the surface, mu, is going to be 0.2. All right. There is a lot to calculate here. And actually, before we go on, let me make sure to link the videos for normal force and gravity and the video for friction, because you might want to go and refer to those. Okay. So to solve this problem, what do we need? We need to find the force of gravity, the normal force, and the force of friction in that order, and you'll see why. And then once we have it, we need to find the net force and the acceleration. And like I said, a kinematics or motion question could always come after that too. All right. Force of gravity is mass times negative 9.8. So our force of gravity is going to be negative 98 newtons. Now, what's the job of the normal force? It is to cancel out the force of gravity and any other vertical forces so that the object can just sit peacefully on the table. Luckily for us, there's only one other vertical force, and that's gravity. So if I want the net force in the y direction to be 0, that's Fn minus gravity equals 0. It tells us that the normal force is going to be 98 newtons. This is something I also see a lot, and I want to warn you against. A lot of times I have kids ask, where is the equation for normal force on the equation sheet? And unfortunately, there isn't one because it really depends on what all is going on vertically. The closest you get to an equation for normal force is this equation. that once we add up all the forces vertically, they need to add up to 0. So it's sitting on the table, not flying up into the air, not sinking down into the table. And that's how we find our normal force. In a lot of cases, including this one, it is opposite the force of gravity. But if I had a little extra force here or a little extra force here, suddenly that would be different, and we would need to take that into account. Force of friction, though, we do get an equation for. And it is mu times the normal force. So that's 0.2 times 98, which is 19.6 newtons. So when we look at our net force in the x direction, which is the direction it's actually moving in, we get 100 minus 19.6 is 80.4 newtons. And then we can take that down for net force equals mass times acceleration, and we'll get an acceleration of 8.04 meters per second squared. But again, for all of these problems, whether it's something like this, where we have to find a lot of things before our free body diagram is complete, or something like this, where all the forces are ready for us, what we're really centering the entire problem around is being able to calculate the net force and using that to calculate the acceleration. All right. Thanks so much, everyone.